You know, Jarrett, we've been working pretty hard pulling some all-nighters to get this daily content out. My system could sure use the boost of antioxidants found in approximately, give or take, these exactly 40 grapes. The only thing is, I wish I could consume them at a faster rate.
No, Rob, that is messy and is generally as unreliable as this engine itself. There's a much better way to get a massive boost of antioxidants without turning this engine into a food processor.
Go on.
Rob, no work is needed to consume Welch's 100% grape juice.
But why?
Because they already crushed the entire grape.
But why?
Because it includes the nutritional benefits that give me a natural source of energy.
Oh, really? Thanks to Welch's 100% grape juice, not only have I been able to push the 4-rotor, but I have the energy to tear apart the 3-rotor. Hi, I'm Rob Dahm, and you are watching how to disable and open a 3-rotor engine. Well, I'll be honest, the first part of disabling was done long ago by me, multiple times. But in this video, we are going to take this engine apart and see what's wrong with it. Obviously, we have a blown rotor. We have this rotor right here is hurt. This iron right here is cracked. The fix didn't work on that one. I have a couple other concerns here while we've been working on this car. One is the condition of the fuel itself. And I really mean the fuel injectors. I did this in a video earlier, but I briefly ran the car without a fuel filter while testing it. And because of these hats, we can't tell what exactly is going on in there. We have to take this hat off of there, so that doesn't really help us. These are the secondary fuel rails. We're gonna take the primaries off, and we'll dig into these as well, because I'm gonna set everything on the table. We're not gonna just assume that something broke. We're going to straight up dig into every aspect of this car. I like to manage by measurement, and the measurement here is going to be the details of what broke. So let's just get these out of the way, quite frankly. That's our first goal. Is I don't want to drop the injectors. These tips are the important tips. I just want to get them out of the danger zone. I'm not covering these because we're taking the motor apart, so anything that falls in there is literally going to be accessible in the next, hopefully, half hour. Not for you. It'll probably be 4 hours for me, 10 minutes for you. One of the goals of this build is to move to E85, and that means that we can go with larger primary injectors. These are the largest primary injectors you can get while maintaining minuscule fuel amounts. So these are 1050X. I'm assuming the X means that they're an upgrade. They are amazing injectors, but these injectors are the biggest primary injectors on a rotary that you can get for regular fuel, not E85, because remember E85 uses 30% more, so you can use 1300 and idle and have the fine-tuned control there, which is what's going to be on my rotary Corvette. Without much more talking, you can see that really all of the end pieces, there's no real damage, which there shouldn't be. There's nothing coming back through this area. Take the gorgeous lower intake manifold off. Jarrett's currently showing you a very, very riveting part of me taking out bolts. Make sure you take out all the bolts relevant to the part that you want to take bolts out of. And ultimately taking all these bolts out will remove the part after you give it a little bit of pressure. So make sure you pull all the bolts. Some will be long, some will be shorter. Some may be requiring more force. Nonetheless, remove all of them before taking the lower intake manifold off. Here's a perfect example of what happens when you don't remove all the bolts. The part doesn't remove. So, and with all the bolts and nuts removed, the part does in fact come off. All jokes aside, like I said, there's still just... There's no oil coming back out of the rotors. Oh dude, it's kind of sick. I don't know if you can get a good shot of this, but look in there. You can actually see what it looks like. This is why rotary engines don't have valves. The rotor itself is actually blocking off the intake. That's where fuel and air go into the engine. Well, on a piston engine that, there's valves that open and close, the rotary shape actually prevents you from letting more air in. I'm not sure what the heck happened here. Obviously we went lean. And so your question about oil getting into places it shouldn't have, that was an issue right here. You see that crack? There's 2 cracks here, just like the first time. But that's not what caused me to stop. That's what Abel stopped on, was this, that was leaking out oil through here. There's a lot of people that make a modification here that shoot oil straight into the bearing instead of going through this channel here. That modification didn't help for some reason. But that's not what caused the engine its real problems. You could still run the engine with oil leaking. You could literally drill a hole through here, have oil pouring out of the motor and make 900 horsepower. That's not the actual problem. It's that this rotor lost compression. I want to know why this rotor lost compression. So we're not seeing anything really clear, straightforward. I mean, you might be like a rotary god, look at it going, oh God, it's just the blah, 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 blah. Cool, that's awesome. But 99% of the world isn't gonna know what is going on until we tear it open. I was recommended to see if the apex seals move, which some of you may know, those apex seals are actually on a spring. Like there's a spring behind it that you can push the apex seal in and out if it's not too corroded. That seal's not moving. You can see it trying to. You can see like the oil moving. It's moving a little bit. Let's compare that to this next one. So this is a known, wow, it's ugly. This is a known high compression rotor. Oh yeah, see that, look at that. That's a properly working apex seal. Even I didn't know this for the most time. You see how that whole seal disappears into the rotor? There's a chance that the rotor can hit the housing, especially if the motor's not pinned, which this one is, and wedge that apex seal down like this, and then what are you gonna get? No compression. So the apex seal can actually be okay, but just wedged in there, and the rotor's actually trash. A lot of people don't realize that's a possibility. So you just saw right there, the apex seal, that's a good working scenario. The apex seal moves. Oh, I can move it by hand too. This is really fascinating for me, because I've only played with them when they're apart. Hopefully that's showing up on camera. It's moving considerably. Just like piston ring, I guess, would be a similar analogy. Let's go back to this one now that we know what is a good example. So that one's fine. This is a different rotor. Apex seal, mind you. See? Look at that. So that one's fine. There is a slight chance digging into this actually unfroze them. And I know that that's not likely for those of you guys that are aware of these. I don't want to speak as if this is a common issue, but it can occur where you just unstick it, especially like engines that have been sitting. This one wasn't, but look at that. That one's definitely stuck. That's the interesting one right there. I think this is the same one I was at earlier. She's not moving. Many of you guys can understand the emotional stress that's coming from what I'm doing right now. This is the correct gasket for this, and it's only gotten a couple miles, maybe an hour of idling on it, and it is like 40 bucks, something like that. So I'm trying to maintain it because I love $40. Many of you might be wondering, especially Abel, as you're watching this video, because I guarantee Abel's gonna be watching this like, Rob, what are you doing? Abel, you know, deep down, you would never let me put grape juice into an engine. And that, my friend, is why I had to do this solo. I need you here. I need your help. I need your guidance. But this had to be done. I know a lot of people look at my stuff and go, Rob, why don't you buy new? That's not where I came from. And that's not what my YouTube is about. That's not what this car is about. The 4-rotor is everything that you're thinking. Oh my God, billet, brand new, perfect. He doesn't reuse parts, so it's perfect and guaranteed. This is the 3-rotor. You guys wouldn't know to even watch this video if this 3-rotor was a purpose, race team, boring ass car. There we go. Required a little bit of work with razor blade. Left a little bit of material on there. I'm not too worried. This thing has never leaked boost before. I'm gonna save this piece. Clean up the ports a little bit. Not that this is really phased to do that, but only because I just made them a mess. Maybe I get to resurface this. If we're reusing any of these irons, this is definitely gonna get resurfaced. I'm pretty sure I'm replacing all these housings just because we tried making it work and we shouldn't have. Well, there you have it. That is the short block, really, I mean, arguably not, but the short block on a 3-rotor RX-7. And the thickness really is apparent right here on what everybody affectionately calls the $6,000 piece, center of the gorgeous, horrible motor that breaks my bank account, the fat iron. This iron, oddly enough, treat it like this. That's a standard 2-rotor configuration for the most part. Big ports out here, little primary ports here, and you can see that they're primary ports because you see that's where the injectors for the primary injectors go. Baby injectors, baby ports, bigger injectors are up here. Life is good, but then we all decided we need another rotor. Actually, the Japanese did, and they copy and pasted this over to here, creating a doubly thick iron. Some of the things that are kind of funny about a 3-rotor is not all of the bolts go all the way through. I always assumed that, like my 4-rotor, all the bolts went from the front to the back like a 2-rotor. Similar to how Mazda built 4-rotors, which I will tell you right now, Mazda built 4-rotors, the 787B, is not built like that car over there, or that engine right there. That is basically, think of it like a shortened, stubby 4-rotor. Mazda's 4-rotors has a middle iron that looks similar to the fat iron on a 3-rotor. So literally this, and then this, kind of like a 2-rotors. You'll see a guy named Mad Max out in Australia, New Zealand. His intake manifolds kind of resemble that sort of mentality, is that it's 2-rotors, and that's really how Mazda treats their 4-rotors. We will not be using this fat of an iron in the middle. It's time to take on our biggest arch nemesis now. Pull the pin, hopefully. Hopefully I can pull the grenade pin on this.
Wait.
There we go. Nope, don't wait, because I'm going to show them. Jared, the people need to see. The people need to see this.
Fine, let them see, yeah.
Okay. Okay, they're ready for this.
Twist it. Oh, and it's leaking.
And it's leaking. That's what I'm saying. That's like, that is not our arch nemesis. Our arch nemesis is the master nut right here that we need to take off next. Oh my god. Oh my god.
I can't even be mad.
I'm not mad. It reminds me of a good story to tell. A cautionary tale to anybody that builds a rotary engine. There's coolant hidden inside of this engine in every crevice. Really, there's coolant hidden all through the coolant chambers in the motor. And one of the biggest mistakes that most people make, and by most people I mean me, because I've never asked anybody else that owns a rotary engine this, the coolant goes in here, obviously, and if you remove your air separation tank, there is so much coolant that you'll miss and almost blow up your motor, because put coolant in here, it fills in, it goes down here, and it goes through the radiator and you fill your radiator. The problem is your thermostat's not open because the car's cold, and this whole internal loop that goes out like this and comes out and then goes back into here is missed. And so then when the thermostat opens up, because it starts noticing heat, even though it's not as hot as it is back here, it's burning to death. Thermostat opens, a little bit of coolant goes in, the rest of the coolant stays in the radiator, and you suffer coolant death. I've been very, very lucky to mistakenly, repeatedly overheat my car because, oh, coolant temps are okay, thermostat opens, that little bit of coolant pops out, and you'll watch my coolant temp go from whatever, 180 to all of a sudden 250, and you're like, you can see there's tons of coolant still in the motor, even though we drained the radiator, we drained everything else. That's just the nature of the rotary beast. I'm really mesmerized. Both Jarrett and I were supposed to be cleaning up spot number 17, and I created spot 18. But I'm not even mad because the coolant's just coming out of this engine, and it's just going and ebbing and flows like. It's just kind of mesmerizing. Since we're at the tail end of being messy, I realized something I had thought a long time ago was slightly incorrect. I always assumed that there was an oil drain plug in this spot. That is not an oil drain plug. It's a coolant drain plug. So, those of you watching this and rightfully being deterred from doing this yourselves, thankfully, this exists. It looks like it should be an oil one too, if you look at it, because it's on oil fill and all that. Even if it is an oil one, it's going to benefit us. We're going to rotate the engine 90 degrees up so we can take a look at the master lug nut. Even though that's not what it's called, that's what I'm calling it. we go. That's how an adult, let it rip.
Where did that even come from?
I don't know. This is the fountain of like youth or perpetual water. We're gonna flip it upside down and actually take off the oil pan itself. This is the original oil pan. This is not something you should be doing in dress clothes, or at least dress jeans. Oh, I can feel it loosening. A rotary engine is a perfect example of something that when you don't have oil leaking, there's a problem. So I wish I had the right tools for the job, but I'm definitely setting myself up to get a built to apex oil pan very quickly. Just being kind, gentle to this one, and then working a blade that is very breakable through the rest of this. You see it's actually starting to slide with ease. There we are. As you can tell, this is, in fact, still a wet sump vehicle. No dry sumps, nothing weird like that. There's the dipstick on the other side, if you've ever wondered what that looks like. So 2 things looking at this engine. One, look at that. What is that? It's metal. I can feel metal in it. Metal fragments. I can't tell if it's like shaving, kind of feels like wool. Interesting, that was on the oil pickup. And that thing's pretty coarse. I'm surprised that filtered anything short of like a bolt. Here's a not so well known fact about the way rotary engines work. I can't speak about piston engines, but this is how rotary engines work. This is the oil restrictor. This basically sets what your oil pressure is supposed to be. There's a little ball in there with a little spring, and when the ball gets pushed against, it creates pressure. The spring regulates how much pressure. So oil pressure regulator would probably be the correct name for this. It isn't what's on the front end. It is actually on the back end of the whole oil system. So oil dumps back out throughout this whole area. What it does is the whole oil pickup driven through here and then pressurizes the oil system. So of course going through the engine and through the oil coolers, and then it goes through all the way through to back here, and before it goes to dump back into the oil pan, this is restricting the oil from leaving the system. So what happens, that backs up all the oil inside of every line that needs oil pressure, including all of the bearings, all of the coolers, everything. And that is what creates oil pressure. So if you unscrew that, or that was to fall out or something along those lines, goodbye oil pressure, even though you have oil in there. It is not just having oil in your engine, but having oil pressure helps your bearings work in engines like this. I went and got a 2 1/8 inch impact socket. That's basically 54 millimeters, which is the correct axle, what do you want to call this? Eccentric shaft nut. Where's 2 1/8? Jared's still tripping me up with all the wrong numbers. So we're gonna use this on this. Of course, that requires the flywheel from being taken off. So we're gonna go ahead and boop, that's off. Wow, don't know my own strength there. And then take this off of a very important surface, and there that goes. Here comes the pain. This needs a impact socket, which is perfect. That's an impact socket. That's not an impact wrench. This is so painful, but we're gonna wedge the counterweight against the iron. What's the worst that's gonna happen? It's gonna totally crack the iron and ruin my life. That's the absolute worst that can happen. So we'll start there, and instead of just hitting this by hand, we're gonna actually hit it with a hammer to simulate an impact driver. Oh! Everybody calls this the keg, and this does feel like it's a keg party, and I have tapped the keg. This to me is like the barrier to entry. If you can remove this, you're doing something you either A, shouldn't be, or B, well, still shouldn't be. really, this is like the point of no return. You're now unlocking the field of dreams, the secrets inside of here. This, I'm curious. See if this just pops off, right? No, wrong, because it's slid on to there. For those of you that aren't familiar, this is just the counterweight for the 20B, the rear counterweight. Using our physics as an advantage, we're gonna put the flywheel back on and then hit the edges of it with a soft blow kind of hammer, something nice. So that way we offset and off balance the counterweight, I'm hoping. There we go.
Nice.
Nice and effective without damaging anything. It's very rare for me. I do actually value this stuff, and That's how you remove all of that without damaging any of it. So this is a seal, of course, but inside of there is going to be an oil bearing. We do have to remove this to remove the plate, the rear iron. All right, we have some weird bolt sizes here. We've got one 12 mil, the rest are 13 or ½ inch, depending on how you want to look at it. And then these bigger bolts, I ended up having to use 13/16, whereas these are 17. I'm still bringing like a trash bag and tons of cardboard boxes filled with like the 3-rotor. I'm gonna be like, Abel, help. These are too important to mix around like that. There. Yeah, this is actually already the exciting part. I mean, this whole thing is exciting. Oh, let me get the key out. There. This is like the nuclear core. And how is my new bearing doing? Fairly decent. You see, this isn't 2-cycle oil. This is all actual real oil, like crankcase oil. It's the separation of zones right there. I'm just seeing if there's any wear, abnormal wear. This one, oh, look at, there's some of the copper. This one wasn't new. This one was actually my old one. You can see the copper color. I personally don't know at what point a bearing is good or bad, but I do know that when you see copper, you know it's not in the best of moments. I might need to replace it. Maybe that's good. I don't know. We'll find out. Oh man, this is irreversible. So is blowing your motor, but just loosen that one. That one's loose. Obviously, even though we're disassembling the whole motor, we don't want crap going into the engine. And that's actually the worst part of the engine to have it go into, because that's more the oiling system. And yeah, there's an oil filter for it. But still, there's a correct order when torquing these on. Regardless, take them off. It looks like all of them. The important part is that we're holding onto the engine at the fat iron. All of them go to or through the fat iron. None of them stop here. They all go through to here or to here. But yeah, that was a eye-opening experience, is going, oh, the 4-rotor, currently all bolts go straight through the motor, which I think is potentially something to look at. But on the 3-rotor, some of them are just the stock 13B, and they literally are the part number, or could be the part number, part of the part number for 13B. It's neat to have somebody else do all this. It really is, because they know way more than you. There's something about pride or respect for your own equipment to be able to do it yourself. And I'm not even remotely assembling it. I'm just disassembling it. So look, Jarrett, Rob. So you can see it goes to the fat iron, like a 13B. This goes all the way through. This engine's been through a lot, and that connects into the fat iron that needs to be replaced. So I think I'm gonna replace this one. I don't know which ones are longer and which ones are shorter. Those are some fat pups.
Those are both Jarrett's.
I missed the opportunity.
You can have the rest, dude.
Yeah, I missed the opportunity. Thankfully that didn't do anything bad to the, oh, there's like a second seal on there. It pulled one of the oil seals of some sort. I'll be honest, I don't know what else is necessary. Those were all the bolts that hold this side together. Abel does have this engine doweled, which means if I pull this off, it's not like gonna de-sandwich, and then it's not like the whole thing can slip inside like this. I mean, sure, like a little fraction of an inch, but realistically, there are things still pinning it in place. Oh my God, it just pulls right up.
Does it?
Yeah, check this out. You ready?
Are
you ready? You guys ready for this moment? This is the moment. This is it. There you go. This is the beauty of the rotary engine. This is what blows my mind about rotary engines. Watch this. I'm gonna spin the rotor, and the actual eccentric shaft has to spin way faster than what you would think the rotor has to spin to do it. Because look at that. It's like twist. See, look at that. See, they don't spin together. See that? The eccentric shaft has to spin more than the rotor does. A quick anatomy of how rotary engines work. These are called corner seals. They literally seal. There's a little bit of a spring right behind there. These are side seals. And that looks springy as well. So those were all, oh, this one's definitely wedged in. Look at that. That whole side's like wedged. Oh my God. This is, you can't feel it, but trust me, that one's flat. These are all actually springing. I'm sure Jarrett's got the zoom on this shot.
Oh, yeah.
You can see that. We suspected earlier, this corner is where something bad happened. There's a seal right here. It looks brown, but that's actually an oil ring, similar to a piston, that prevents oil that's in here lubricating the E-shaft to going out into the combustion chamber. There's kind of like a dead space between this one and this one in this area right here, because the combustion is supposed to be happening out here, and it leaks. You can see it a little bit leaking to this very edge. It's just the nature of the beast. Now, if this was just me and Abel wasn't involved, I would in fact put the engine back together with these coolant seals and just hope for the best. That would be okay to me, but I'm also not an engine builder, so I don't know what that would do long term. This has been in this engine from the beginning. Definitely blur this out. I can see it, I'm touching it, but you guys are seeing a blurred finger as well as blurred port. That's my luck. But you can start seeing circular shapes, which is fascinating because there are circles hidden inside of the shape of a rotary engine. My side seals did a lot of damage. There is a step right there. I assume this is still usable though. So air in through the side, that's called a street port. Combusts over here, which is why this side's got more damage. That's where shit gets pushed harder. And air comes out the center housing here. All right, this is basically the heart transplant right now. I feel so excited for this. So as you can see, the seals are coming out of the ones that aren't broken. They may be reusable. Look at all that sludge. That is an apex seal. There are two little springs behind each apex seal. Sometimes those get flattened. Sometimes they choose not to cooperate. But this is the apex seal in all of its glory. So something that does concern me and explains why this thing had no compression on any face, the tip of that apex seal isn't shiny. Normally when you pull apex seals out, they're super shiny along this edge because they've been dragging along the rotor housing and, sharpening their teeth more or less. Because the spring behind it is basically pushing the apex seal into this housing at all times. That's the whole point, to create combustion and to create compression. Wow, this thing took a beating. I don't even mean like an actual beating. Like it just looks bad. So here's the one in question right here. We thought it was stuck when we had it in the engine. We pulled it out of the engine and it's still stuck in its spot. Again, the rotor itself is made out of a real man's metal. It's made out of iron, steel. Yeah, that definitely got look at that. The side seal's wedged, apex seal's wedged. They're not moving. I used more than one. I mean, the engine ran lean. Look at that, dude. Pull this off. Just to give you, I'm moving the light to really show the three-dimensionality of that. She took something. Yeah. And with the way the rotor spins, air gets sucked in. That's definitely the part that's sweeping it out. So that's where you're going to get damage. A lot of damage on this side of the rotor as it spins this way. Again, this car went lean, very lean, several times in a row. And we're seeing a lot of symptoms of that. I think this is what you call two-piece. This completely looks like a chunk of waste. This doesn't even look like a real thing, to me anyway. But it very much is. It's an actual design in a two-piece apex seal. I used to call these the corner seals. They aren't. They're just the second part of the apex seal. So there should be a second corner seal on the bottom here. But the seal goes like this. Why does it have two pieces? Well, same general concept is that this can get wider and seal things off more as time goes on. Kind of like, what is it, moles? Where their teeth are constantly growing so they can just keep sharpening them. This has a finite amount of resource, but it definitely allows the engine to continue. Oops, sorry, showing you guys the wrong way. That's not I want to make sure you guys see it correctly.
Oh no, did it just drop down there?
Oh no, I just lost part of the quarter apex seal. Okay, well that's definitely important not to lose. But I was holding it the wrong way. I wasn't paying attention. But you see how there's these grooves right there and there? Those are for that shorter spring. And then this longer spring hits this groove right here. And the piece that just completely got destroyed, it touches that piece right there. So that way the apex seal sticks wide too. You know, not just up, but wide. Wow, this looks bent. Man, she took some serious damage. I'll be honest, I don't know if that's design, but I remember all of them going in and they weren't bent. I just want to see if this other one's bent like that. These engines will leak oil. The rotor has so much oil inside of these holes. You see it already leaking. It'll do that for like weeks. And then we're going to pop out the springs and see if they're bent. If that's a common thing. No, they're not. That's a nice, simple curve. So there's damage to this one right there. Confirming that. Whoa. Whoa. Whoa, 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 whoa. Something took a hit hard, which that adds up to, what the hell is that? Because there's the other damage that we were just looking at, and then that damage right there. Wow. I don't know what that is. Nothing's missing at this moment. But wow, there's some weird damage to this. I was not expecting that. It chewed through the, look at that, it chewed straight through the side seal. That side seal got pushed in. That chunk goes straight through. Look at that, there you go, that's a perfect example. Pushed the center of that side seal in. Something bad happened to this. This is beautiful to go and explore. There's a lot of that damage. Something definitely came into the rotor assembly, into the combustion chamber, because this one's a really deep groove. This is going goodbye. But Jarrett pointed this out. Look at that. That wasn't there before. That wasn't a. The rest of this is going to be blurred, but that's not a chunk made from the guy with the Dremel. I literally watched and filmed them making these. That something came in and hit partially right there. Whatever it was, hit right there and hit the rotor as the rotor swiped past it. So that chunk and this are directly related. And since none of the side seals, none of the corner seals, none of the pieces are actually missing, aside from the one that we just dropped into the engine. Aside from all that, that is something from external, came in from outside, which is one good reason to not run the air filter. All right, in efforts to show you guys just the things that feel so unknown when taking an engine apart, Jarrett and I just did this and realized, oh my God, let's film it. Yet another pile of oil to add to the mix as soon as we get done filming the fun parts. This is a 34 millimeter bolt head, or nut, however you want to look at this. Basically, I guess you consider that a nut. That, we actually did very fancy ways of getting that off without hurting anything. There's my 36-2 timing thing from Full Function Engineering. Pretty solid there. So I'm gonna take this whole plate off, and the reason I'm doing all of this is because getting any further back here to gut all of the sugar-laden grape juice pieces, you have to undo the front part too. So I put the flywheel back on briefly so I could have the counterweight chuck and just gently in there, so that way we could balance off that. Like I said, 54 millimeter in the back and 34 millimeter in the front. Tang Tools 3/4 inch drive set made all of this absolutely possible. So we're gonna continue taking this down, and then in the next video, bring these pieces to Abel. All right, well, here is a chance for Abel to use his master rotary skills to see if he can figure out what happened to this motor. I genuinely, it went in there. Oops. I wondered why it was coming out of the other ports. It did a pretty good job at it. But look, I was wondering why it was coming out of the bottom port. It was coming out of this port as well. It went into that next rotor. Well, this is a pretty good sign of it's time to rebuild your motor anyway. Oh my God. We're gonna go ahead and disassemble the engine more for the obvious reason of preventing all this from rusting and sticking, because this is already getting sticky in my hands. I feel bad for this motor.